Hi everybody, this is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. We are seeing the lecture series of videos on the topic, subject, measurements and instrumentation. The subject is for second year EEE students, a basic course for measurements and instrumentation. We have already completed unit number 1, the various comparative methods of measurement is the unit number 2. Come, let's get into the video. The first topic what we are going to discuss in today's video is about the DC potentiometers. Let's have a small recall about our previous topic. Previously, we were been discussing about the various concepts or basic concepts of measurements and instrumentation. We have just discussed in unit number 1, what are measurements and instrumentation? What are the various fundamentals quantities of measurement? What are the characteristics, static characteristics and dynamic characteristics a measurement device provide? We have also discussed about the various statistical treatments. We have also discussed about the various errors occurring in an instrument. Also, we have discussed about the various types of standards and calibrations in a measuring instrument. A brief introduction about the DC potentiometers. What are DC potentiometers? So the DC potentiometers are a precision measuring instrument using null deflection method. It compares unknown voltage to a known standard of voltage. It is used to find out an unknown value of voltage at any point of contact. It has a high level of accuracy. Voltage measurements is up to micro level we can measure. What method is used here is the comparative type of measurement. Sensitivity detects the smallest voltage change. Why we need to go for this measurement is the empathy part. Because it can detect the smallest change in voltage. It is very precise. Consistent repeated measurements are possible. Millivolt to 100 volts, standard for the instrument. Various applications are there for the DC potentiometers. That is voltage measurements, current measurements, resistance measurement, and instrument calibrations. Let's see the working principle of a DC potentiometer. The unknown voltage is compared to the reference voltage. Sliding contact is adjusted until the galvanometer shows a null deflection which is equal to 0. No current flows at balanced point, that is zero consumption. Let's see the diagram of this DC potentiometer. Here shows the circuit diagram of a basic slide wire potentiometer. You could see a blue color line. That line is a calibrated slide wire. You could see the values 0, 50, 100, 150 and 200. There is an unknown value of EMF connected across. There is a toggle switch which changes between the unknown EMF and a standard cell. And another point is connected through a galvanometer to the sliding point of contact. The whole system is connected to a battery source through a rheostat. So based on the supply given, the sliding contact moves on the sliding wire and the unknown EMF is on the other side. During the operation, both the values get compared. The sliding point contact gets moved till the galvanometer reads 0. That is, it should read null deflection. At the point where the null deflection is noted, the sliding contact stops. That value is taken as the even value, which is measured across an unknown value of EMF. The null deflection is the point where we get the known value of EMF, that is E1. In order to calibrate, we are going to toggle the switch from the unknown EMF to a known standard cell for calibration. Known standard cell, we already know the value. Now the sliding point contact moves. The point where the null deflection is noted, the sliding contact is made to stop. Now we are going to check the standard cell value and the sliding point contact value, both remains the same. Or it is going to be adjusted regarding to the same. So this is about the working of a DC potentiometer. The key concept here is the null deflection. The measurement is based on balancing voltages, ensuring the potentiometer draws no current from the circuit being measured. The mathematical formula is given as V of x is equal to VR into L divided by Ly, where V of x is an unknown voltage, VR is the reference voltage, and L by Ly is the length ratio of the slide wire. There are various types of DC potentiometers. Simple DC potentiometer, what we have seen now as an example, Crompton's potentiometer, Vernier potentiometer, etc. All these changes, basic construction is straight wire uniform resistance. The key feature for a Crompton potentiometer is uses a standard voltage ratio for accurate measurement. Enhanced precision incorporates vernier scale for adjustment and readings. Their operation includes various standardization advantages. All those things are listed over here. What are the various applications? As we saw about, do we directly measure the EMF, that is the voltage, which is accurate to determine the batteries and for cells. Current measurement is possible by just knowing the values of voltage and the resistance. Indirectly, by calculation, we can measure the current value. It's a complete concept based on position and displacement. It can also be used to measure the resistance. It is also used for calibration of the instrument as we connect the standard cell and calibrate the process. A small case study. Temperature measurement system in industrial process and research laboratories. Thermocouples require precise calibration to ensure accurate temperature reading across wide range. The measurement process uses DC potentiometer to measure the EMF at different temperatures, compare with standard reference cell for absolute accuracy, create calibration curve, mapping voltage to temperature. The results and benefits are the enhanced calibration accuracy to plus or minus 0.1 degrees centigrade, improved temperature measurement reliability, compliance with ISO 9001 quality standards. What are the various advantages and limitations? It has high accuracy, no power draw, precision in measurement, wide measurement range. It also has some various limitations, time consuming, requires standard cell, complex setup, temperature sensitive. So summary, we just going to start about the bridges. Before starting the bridges, we are just discussing about the DC potentiometer. The working, why do we go for DC potentiometers? The empathy part, the ideate part, what are the different types available? Why we are choosing a simple DC potentiometer, and what are the various applications of potentiometer? So with this, we'll try to finish this video. Oh, we will see the next topic of AC and DC bridges. Thank you.